Right, welcome to your recording for the activity 12 and 13 review in preparation for the Green Monster Embedded Assessment. So again, as always, I'm just going to go through a few of the problems, not all of them, but just a few of them. On the first section, numbers 1 through 7 were all on, it's really all part of the same problem. So hopefully you were able to fill out your chart correctly. If you look at the answer sheet and look at the information that they gave you in the problem, it told you that the price per ticket decreased by $1 for each additional person that you have. So you knew it started at 44 for 2 people, so you should have just gone down 43, 42, 41. Now, some people had some trouble then writing the expression that represented the cost per ticket for X people. So again, you know that what you're doing each time is you're subtracting based on the number of people. So you're subtracting one more for each additional person that you have. So because of that, you should know that the expression has minus X on the end of it. It's just making sure you can fill this in that some people seemed to have a little trouble with. So again, you have to fill this in so that when you plug in 2 for X, you get 44. When you plug in 3 for X, you get 43. So the number that has to go here is 46, because 46 minus 2 gives you 44, and 244 is what's in the table. 46 minus 3 is what gives you 43. So all you had to do is figure out essentially the starting point. So 46 minus X was your answer for number 2. That's how you should have found it. Really, it's kind of a guess and check. You could have, I guess, set up an equation where you made 46y and you just did this and you said, I know that y minus 2 has to equal 44. So I guess you could have done it that way to figure out 46. But either way, again, your answer is 46 minus X. This, again, represents the price per ticket. So number 3, some of you were trying to run a quadratic regression on the table from number 1. The table from number 1 is not representing the cost for a group. It's representing the cost per ticket. So you can't run quadratic regression. That chart doesn't apply there. Number 3 wants you to write an expression for the cost of the whole group. So what you're doing is you're taking the number of people in the group, which they told you in number 3 was X, and you're multiplying it by the price of each ticket, which is what you did in number 2. So 46 minus X. So number times price gives you total cost. It did ask you to write it in standard form. So that's how I ended up getting my final answer, was distributing. So I distributed, and then of course I put the negative x squared first and the plus 46 afterwards. Number 4, I'm not going to do the whole thing because we've done countless numbers of graphs. But of course you need to make sure that you label your axes, choose an appropriate scale. Really, I would have just made a t-chart. You have the function right here, so I would just make a t-chart and plug various numbers in for x and plot the y's that go with them. I counted by tens when I made my graph. Remember that you can't just pick all points that are close together. You need some on both sides of what will be the vertex. So I just made a t-chart and went from 0 to 40, counting by tens on my x's, and then just plugged them in to get the points. When you look at the graph, and again, I'm not going to draw it. You should have the graph in front of you. If you need to pause this recording for a minute to make your graph based on the t-chart, you can. But when you are looking at the graph, I will just draw a rough sketch here. It looks something like this. Number 5 asks you the intervals for which it's increasing and decreasing. So we did one just like this in the lesson, in 12.1, I believe, remember that it increases this whole way. And then this whole way, it's decreasing. So all you need to do is find the x value of the vertex. So yes, you should know how to do that. Opposite of b over 2a. So the opposite of b, because b again is 46, is going to be negative 46. So negative 46 over 2 times a, which is negative 1. So negative 46 divided by negative 2 is positive 23. So that is how I got the 23 that's on my interval. So it's increasing when x is less than 23. It is decreasing when x is greater than or equal to 23. And number 6 then asked you to find the vertex. We already needed to find the x-coordinate for increasing, decreasing, which is why this is the next question. To find the y-coordinate of the vertex, you should be plugging in your 23. So negative 23 squared plus 46 times 23, which is how I got my y-coordinate, which is 529. So vertex is at 23, 529. So that's my work here. Again, this was my work for number 5. I don't think 7 was hard. I think the answer is pretty self-explanatory. Number 8 asked you to write it in standard form and then find the vertex. So writing it in standard form, remember, requires you to FOIL. So you've got 4x minus 4 times x plus 5 was your problem. So firsts, outsides, insides, and lasts, and then just simplify your middle terms. Once you've done that, which gives you a plus 16x, then finding the vertex, we do the exact same way I did in 5 and 6. You have to do opposite of b over 2a, and then once you get that x-coordinate, you plug it in to this function to find the y-coordinate. You must have work shown on this review for credit. Do not just write the answer and write the vertex without showing me your FOIL, your opposite of b over 2a, all of that good kind of stuff. All right. 15, 16, 17 ask you for key characteristics of the parabola. Both 15 and 16, when you solve the quadratic, they were factorable. So I'm going to choose 17 because 17 was the one where the X-intercepts were a little trickier than the others. So your original on 17 was f of x equals 2x squared minus 12x plus 13. So it asked you for several things, first of which was the vertex. So again, we've done a lot of that already. Opposite of b over 2 times a. So 12 divided by 4 gives me 3. So that means that the x-coordinate of my vertex is 3. To find the y-coordinate, I need to plug it in. So 2 times 3 squared, which is 9, minus 12 times 3 plus 13. So this gives me 18 minus 36 plus 13, which gives me negative 5. So y-coordinate of my vertex is negative 5. Y-intercepts. Remember that I find y-intercepts by plugging in 0 for x. So if I plug in 0 for x, that gives me 0 minus 0 plus 13. So my y-intercept is 13. Remember to list it as an ordered pair. 0, 13 is the point that you're listing. X-intercepts are the ones that require the most work. X-intercepts, remember to find them, you plug in 0 for y, or in this case f of x, and you solve the quadratic. So 0 equals 2x squared minus 12x plus 13. So again, typically I would try to factor this. If you try to factor it, you're looking for what multiplies to 26 and adds to negative 12. and you find that there isn't anything because your factors of 26 are 1 and 26, they'd be negative since this is a negative, 2 and 13, and that's it. And neither of those add to negative 12. So factoring doesn't work, which means you can either complete the square or use the quadratic formula. Most of you would probably use the quadratic formula. I completed the square, but many of you might prefer not to because this is not 1. So it's up to you again. So quadratic formula opposite of b would be 12 plus or minus the square root of b squared. Negative 12 squared is 144. Minus 4 times a, which is 2, times c, which is 13, all divided by 2 times a. So now it's just a matter of simplifying. So I've got 12 plus or minus the square root. I know it's going to be a minus because there's only one negative, so I just have to figure out what 4 times 2 times 13 is. 4 times 2 is 8, and 8 times 13 is 104, so I've got 144 minus 104 in here, and 2 times 2 on the bottom gives me 4. So 144 minus 104 is 40. So now in my next step, I've got 12 plus or minus the square root of 40 over 4. Again, do not try to reduce the fraction until after you have simplified your radical. Radical 40 is 4 times 10. So that becomes, since 4 is the biggest perfect square, 2 radical 10. Radical 10 doesn't break down because even though it's 2 times 5, nobody has a date. So nothing gets to come out. So that gives me 12 plus or minus 2 radical 10 over 4. And now I can reduce. They're all divisible by 2. So 2, 1, 6. So you can either leave your x-intercepts 6 plus or minus radical 10 all divided by 2, or you can divide the separate pieces out and make it 3 plus or minus radical 10 over 2. I listed it the second way, the a plus bi type way, on the answer sheet, but if you left it like this, I wanted to do this one just to point out that your answer isn't wrong. It's just in a different format. So you can list the x's like that. Remember, the x-intercepts are ordered pairs. The y-coordinate is 0. So those are your x-intercepts. The other two things that it asked for are relatively easy to find. The axis of symmetry, you should know, is a vertical line, which means it's x equals, and it goes through the x-coordinate of the vertex, so 3. Then the last thing it asked, does the graph have a min or a max, and what is it? So you have to look at the vertex and the way that it opens. This opens up, which means I'm going to have a minimum, a low point. And the y-coordinate of the vertex is the minimum, so that's why I wrote that we have a min at -5. So that reviewed a whole bunch of stuff all in one problem. How to find vertex, y-intercept, x-intercepts, axis of symmetry, min or max, all of those good types of things. 20 and 21 is a real life situation, so even though I'm not doing those problems because it's the same type of thing that we've done before, I just want to point out to you that you should be doing on your graphing calculator. So the process for 20, and I wrote this out on the answer sheet too, for number 20, you're just graphing h of t in your y1, you're graphing y equals 10 in your y2, and you're finding the intersection points. Now 21 does ask you to verify graphically and algebraically that it reaches 12 meters. So graphically, you do the same thing that I just described in 20. So graphically, for 21, in your y1, you have -5x squared plus 15x plus 1. And then in your Y2, you're putting in 12, and you're finding the intersection points. So remember that that is second trace, choice 5, the intersect feature. So that's where my two answers come from. When you do the intersections between these two, you should get about 1.3 and 1.7. Algebraically, you can show that it reaches there two different ways. You can either actually solve it, so do 12 equals negative 5x squared plus 15x plus 1. So subtract the 12, and actually I moved things this way so that it would be positive. So positive 5x squared minus 15x, and then plus 11 equals 0. So your choices, you could either solve this by completing the square of the quadratic formula. It is not factorable. So if you solve it all the way out, you should get 15 plus or minus radical 5 over 10. So yes, there are two real solutions. They're irrational, but they are real solutions. So that's one option, is to use the quadratic formula to come up with this and use that in your explanation. I, again, shortcutted and just used the discriminant. So I just found that my discriminant was 5. So if the discriminant is positive, then that means that there are two real solutions. So again, several options there for how you could correctly work that. Um, 25 just asks you to do what I just did in 21. So find the discriminant, which is b squared minus 4ac, and then describe the nature and the type of the solution. So again, if discriminants are negative, this is very important that you know your discriminant chart. If it is negative, that means there are two complex conjugate solutions. If your discriminant is 0, that means there's one real, rational solution. If your discriminant is positive and it's a perfect square, then that means there's two real rationals. And if it's positive but not a perfect square, that means there's two real irrationals. So that's the case that we had in 21. So 25, you need to do the discriminant, use this chart, and then it actually wants you to finish solving to find the x-intercepts. So again, quadratic formula, since you've already done the discriminant part, that should make the quadratic formula easier. 26, 27, and 28 are all based on this. So this chart right here is how you're going to know the answers to 26, 27, and 28, plus knowing that the number of solutions is the same as the number and type of x-intercepts. So if there's two complex conjugates, you have no x-intercepts because there aren't any real solutions. They're complex. So that chart is what you should use for 26 through 28. 29 and 32 were both the inequality graphs. And again, when we had done this, I had said that you could use your graphing calculator on these, that you did not need to work them out by hand. But do keep in mind that these are not sketches. These are actual graphs, which means you need exact points marked on it. So for number 32, you can use your graphing calculator to find the items if you want. Some people might prefer to do it by hand. It's up to you. But you need to actually find points to plot on the graph. So I just found the x-intercepts, the y-intercept, and the vertex, and I plotted those, and then I used my graphing calculator to shade. So this guy was factorable if you were doing it by hand. Remember, you have to take out the negative first, and then it's x minus 4 times x plus 1. So your x-intercepts are 4, 0, and negative 1, 0. I know that my y-intercept, when I plug in 0 for x, is 4. So my y-intercept is at the point 0, 4. I know that my vertex, remember the x-coordinate is halfway between the two x-intercepts, so you can either do 4 minus 1 divided by 2 to get an x-coordinate of 1.5, or you could also have done opposite of b over 2a with the original to get this x-coordinate, and then I plugged it in to get the y-coordinate, which was 25 over 4. So I just took those points, I plotted them, so y-intercept at 0, 4, right here, negative 1, 0, 4, 0, 1.5, 25 over 4, so that's 6 1/4. So 1.5, 6 1/4, and I knew it opened down, so I connected it. Because it has the equals, I know it's solid. And then the shading, you can either use your graphing calculator to help you, or you can pick a point. If I pick 0, 0 and plug it in, 0 less than or equal to 0 plus 0 plus 4. Is 0 less than or equal to 4? Yes, it is, which means the point 0, 0 should be in the shaded region, so you can shade inside. Again, you don't have to show all of this work because you were allowed to use your graphing calculator on this one. But I'm just showing you in case you would want to do it by hand. If you are not proficient at your graphing calculator, you could get this answer all by hand as well. So that's activity 12. Activity 13. The first 5 problems were all, again, related to the same situation. And I'm just going to give kind of a verbal explanation because there isn't really work to show, because it's all about reading the information that they gave you and applying it. So some people had trouble writing the equation for number 1. It told you how fast the keys were going. That's a rate. Remember that rate of change is the slope. So they told you that the keys were going at a rate of 0.75. So that's how I got 0.75 for my slope. So g of x equals 0.75 x. And then they told you that Lori's hands were 9 feet in the air when she's trying to catch them. So that's a y-intercept. That's the height, how high up we're trying to get there. So that's where the +9 came from. So if you were clueless as to how to do that, go back and read the question again. You'll see that they're giving you the rate and they're giving you the y-intercept. So this is actually less work than what we had to do in some of the ones in class where we had to do like a y2 and minus y1 point slope format. So number 2, you do run a quadratic regression on, I think. Oh, nope, I just looked at my work. That's for a later problem. We'll get to that in a minute. The quadratic that is listed as the system in number 2, they actually gave to you in the question, so you didn't have to do any work for that. So number 4, you are solving the system. 3, you can use your graphing calculator to come up with the points. Again, don't forget to label. It's a real life situation. But number 4 is the same as what we did in a previous problem. You have to graph g of x in your y1, and then you have to graph the other equation in your y2, which was negative 16x squared plus 25x plus 5. So graph them both. Pick an appropriate window, and then do second trace intersect. That's how you come up with your answers there. 6, And 10 and 11 were all systems that you were told that you could solve graphically, and it did not ask you to actually graph it, which means that you can just plug them into your graphing calculator and look for the solutions. Number 6, you actually had to find them. So in number 6, you need to do a second trace intersect. In number 10 and number 11, it just asked you to say how many solutions there were. So when you type what they gave you into the calculator on 10, you get a picture that looks something like this. So that's why I wrote no real solutions, because there aren't any intersection points. Same thing on 11. It didn't ask you to find the solution on 11. It just asked you to say how many there were. And if you graph the equations that they gave you in 11, you should see that there's just one real solution, one intersection point. All right, moving on. So 18 and 19 ask you to solve algebraically the system. Number 18 is probably a little more difficult because of the squaring out as far as amount of work, but number 19 can be tricky too because of the fraction. So it just kind of depends on where your area of weakness is. So I'm going to set both of them up for you. I'm not going to work them out fully to completion, but I will set them up for you. So remember that when you are solving these systems, you are taking the two problems that were equal to y and setting them equal to each other. Now I need to solve that quadratic. On the left side, that's as simplified as it can get, but on the right side, I need to do some work. You have to square this out first. You can't distribute a 3 when there's an exponent. Order of operations says exponents first. So when I FOIL this out, you get x squared minus 8x plus 16. It has to be FOILed. Do not just try to square the x and square the 4. Must FOIL. So once I've done that, then I can distribute my negative 3. So negative 3x squared plus 24x, because it's a negative times a negative, and then negative 3 times 16 is negative 48, and then I've got my plus 2. So I'm going to move everything to the left side in this case because I like for my squared term to be positive. I'm going to combine these like terms first. Those together give me a negative 46. So when I'm moving it over, that's going to be a plus 46, so those cancel. Minus 24x, and then plus 3x squared, So that gives me 3x squared. 6 minus 24 is negative 18x, and then negative 31 plus 46 gives me a positive 15 equals 0. And from here, this is factorable. So when you factor here, take out the GCF first. They're divisible by 3. If you forget that GCF, you're working with bigger numbers. You're making your life much harder. Now this is the easy type of factoring, what multiplies to 5 and adds to negative 6. So that would be negative 5 and negative 1. So that's how I got my x coordinates. 5 and 1 are the x coordinates of the intersection. Remember, you have to plug them back in to get the y coordinates. I plug them back into the linear piece because it's easier. So 30 minus 31 is negative 1. So that's how I got this ordered pair for my intersection. When I plug in 1, 6 times 1 minus 31, so 6 minus 31 is where I got negative 25, and so those were my intersection points. I said I wasn't going to do the whole thing. I kind of forgot, and I did, so that's bonus for you. 19, I'm not going to do the whole thing, but here it had decimals in the original problem, and certainly you could solve this using the quadratic formula with your decimals, but if you look at the decimals that they gave you, You should know what these are as fractions. This is negative 1/2 x. This is positive 1/2 x squared. The reason I point that out is because your life would be so much easier if you just got rid of the decimals or fractions by multiplying the entire equation by 2. So if I do that, then I end up with negative x minus 2 equals x squared plus 6x minus 10. And then I move these over to the other side, so plus x plus 2 plus 2, cancel, cancel. So I've got x squared plus 7x minus 8 equals 0. And now it's easily factorable. Again, you follow the same process as in 18. So if you didn't do that, again, you can still get the right answer using the quadratic formula with the decimals, but this is much easier. It's a lot less work, a lot less calculating. So be on the lookout for things like that. Remember, you can always get rid of fractions by multiplying everything by the least common denominator, by the LCD. All right. On the end, the last couple of questions that were all, again, over the same part of the problem, numbers 25 through 29. So on these ones, you were talking about the regular glass and the non-glare glass. I think most of the people that I've already helped with this, they really weren't reading very carefully. Note that the table that they give you is representing the charge for regular glass. And I had people in 25 who were trying to use that table. The table is not for 25. The table is for 26, for regular glass. So number 25 just asks you to write a linear function that gives the charge in dollars for a piece of non-glare glass whose longest side measures x. Number 25 is from the information, from the words. It says right in the problem, for a piece of non-glare glass, the charge, so f of x, is equals the length of the longest side in inches, which they told you in 25 was x, multiplied by the rate, or slope, of 75 cents per inch. So times 0.75. So that's all I did to come up with the answer to 25. Again, we wrote that like this, of course, finally. But 25 isn't from the table. 26 is from the table. 26, you have to put the table in your y1 and y2 and run a quad regression. So that is how we got the 0.015x squared plus 0.15x. It's from the calculator, from running the quadratic regression. So the only thing left to do then is to make sure you can do 28, which is the algebraic explanation of those. So if you set the f of x function from 25, which is 0.75x, equal to the function from 26, 0.015x squared plus 0.15x, to solve this, we would move this over, and we'd have 0.015x squared, and then 0.15 minus 0.75 is a negative 0.6, so minus 0.6x equals 0. Because it's asking for the intersection points. Now certainly you could use your calculator too, unless, oh no, it said solve by substitution. I knew there had to have been a reason I didn't do it a quicker way. So solve by substitution, this is factorable. It has a GCF of x. So take the GCF out, 0.015x minus 0.6 equals 0. So take this, x equals 0. and then set this equal to 0. So you'd be adding the 0.6 and then dividing that by the 0.015. That is how I came up with my 40. And then, of course, once you have the x coordinates of the intersection, plug those in to this to find the appropriate y's. So that's how I got 0, 0, and 40, 30. 40, 30 is the only viable solution because remember that x stands for the length, the measure of the side of glass. You can't have a piece of glass with side length 0. The glass wouldn't be there at all. So that's why we have to toss this one out when we get to number 29. All right, so I think that about covers it for activities 12 and 13. Please make sure that you read through and attempt to work out your embedded assessment as preparation. Happy studying!